Chris here from AV.technology. I'm here with Ryan from Miri. Thanks, Ryan, for spending the time with me at InfoComm 25. Much appreciated. I'll kick off with a question. What is Miri's big idea? Start there.
Well, the big idea kind of started from my personal days in broadcast and live streaming, where we were just challenged with getting a great internet connection no matter where you go. And so the whole concept was, how could we create a unit that was so versatile and flexible that you could throw in something like Wi-Fi from a venue behind a captive portal, some cellular connections, maybe even hotspots from your phone or other, with a bunch of Ethernet ports that it could be in WAN or LAN mode. One simple box to do it all, powered by Speedify.
So what were we doing prior to your big idea?
So I owned a production company before I got involved with Magewell and with mobile video devices in the US. I had a production company in Maryland, and we produced live events. The live event where the Miri router was born out of was actually live streaming the Lieutenant Governor of Maryland and a couple of senators at a conference center in Annapolis, and that's where the whole idea was born. So having the background of still producing stuff, and in fact, just a couple weeks ago, I produced graduations for a county school system, so still remaining involved to some degree keeps me kind of fresh with the industry.
So technically, what did the industry do to stay connected if it didn't have it all kind of bonded in one box like Miri does now?
Yeah, sure. So traditionally, people would use devices like a bonded video encoder that's a single purpose device, but when we have devices that are NDI connected and they all want to talk to their cloud servers for remote management or maybe updates, when you can bond at the very beginning of the network, everything else has a better connection. So I like to think of this like, as I'm running a live stream, I also want to monitor the chat, verify that the video is going out properly, the overall health. Well, with a bonded video encoder, none of your other downstream devices get advantage of that bonded connection. But when we have something like a router, now everything across the entire network has that benefit.
So explain to me what Speedify is.
So Speedify is a service, and they're based out of Philadelphia, Pennsylvania, but they have these servers all over the world. And what they're doing is creating a VPN tunnel of bonding packets together, so more resilient connections. Speedify has a very large user base already, and so we were familiar with them because they had PC and Mac apps and also iOS apps, but they had never put anything in hardware. And so we approached them, and we now have the Miri router, which is the first official powered by Speedify hardware, but it incorporates all of that technology into the router. They also have very unique things like pair and share, for example. So the router over Wi-Fi, you can share your phone's connection running the Speedify app into the router wirelessly, which is fantastic because now it's not just, say, the 7 or 8 physical connections of the router, but you could add 20 additional devices of their data shared into the router as well. And there's unheard of for that many type of data connections inside of a box that size.
So technically, how do you guarantee the solid connection within the router?
So guarantee is a hard word to use, right? We like to use it, but it is a very hard word to use because every situation is dependent. We come to a venue like this at InfoComm, and you find that, arbitrarily they kind of crush like the AT&T speeds. Verizon runs really fast. Site surveys certainly help a lot with that. But when you can aggregate all different types of connections, so depending upon where you live, in the US we have excellent Starlink service, and so if we use something like a Starlink Mini, well, all the people in a venue like this, no one else is going to be carrying around a Starlink Mini. That's one way to add the differentiating factor. Then you add in your cellular connectivity. One of the things that we've done is make sure that we put a 4G only modem into the device. And a lot of people ask us, say, why didn't you just do 5G? Well, in fact, what we find and what we hear from a lot of people is that there's a lot of bandwidth on 4G that goes untapped because all of our devices, like phone-wise, tend to go to 5G no matter what. Even if it's oversaturated, the tower's filled out, and the overall speeds are low, it stays locked onto 5G. But one of our tricks is, yes, it's a little bit slower speeds, but from the purpose of aggregation, 4G is oftentimes enough to serve as that buffer for what 5G can't perform.
Right. So in my mind's eye, I'm imagining a bunch of different roads, like a 4-lane highway and a sort of a dirt track and a bunch of different roads in between, and the data is kind of just finding its way as best it can through those pipes.
Correct. So if you could imagine, it's like the Autobahn, right? That's our fiber connection, super high speed going down the road, but you've got your off-road truck. And that could be something like a satellite connectivity. And we're not talking about Starlink, we're talking about like, something K-band or something like that that has extremely high latency. What we're doing is crunching those all together and optimizing the path of which those things take. So within the router itself, you can have a primary connection, secondary, backup, or maybe never, right? You want to keep it connected, but you're physically turning off that device. You could be making that decision based on latency, speed, or maybe data cost. So for example, something that's not costing you a lot of money to stream with, you could have those set as primary. But a more costly data package, you could have that set to secondary. It will automatically use it when it needs to, but that's not going to be the primary route or path that it takes.
So how does this solve, like how much of a headache is this taking away from people, and in what sort of applications?
So we've seen a number of different applications. The box was built because of my experience live streaming. So that's why it has NPF, hot swappable NPF battery, DC power, so you could use something like DTAP or just a regular outlet. But the challenge it has solved initially was for broadcast live stream, but we've seen applications from business continuity to point of sale applications. We've been reached out by a large number of festivals who have said, when we can't sell our merch or our beer, we lose a lot of money. What can we do to help solve that problem? So the Miri router is perfect because now the venue could stand up something and aggregate data together, thus keeping their POS sales online. So it wasn't even a business use case that we had initially envisioned, but it's certainly something that we're looking at now saying, doesn't every business just need better internet? I think of our warehouse, for example. We have cable internet at our warehouse, but inevitably it goes down every other week for, let's say, 10, 15 minutes. We can't ship packages. By introducing the Miri router, now our entire operation stays online. And who nowadays doesn't need internet to do any parts of their job? Everything is on cloud. They have VoIP phones. So this adds that business continuity as well. So applications not just in the live stream and broadcast, for sure.
So it's almost like the equivalent of a diesel generator in the car park.
You're correct, yeah.
So Ryan, thank you very much. Appreciate your time, and it's good to get a sense of what your product is from the horse's mouth. Well done.